Operations with rational exponents. Okay, at the top of your notes it says it has a place for the product rule and the quotient rule. These are going to be two important exponent rules that we use in this concept. So this might be something that you want to write down, these two rules that I have in red. Okay, our first set of problems says use the properties of rational exponents to simplify each expression. So first of all, with number 1, we're going to use our product property. We have the same base, they're both 7s, so we're just going to add the exponents. 1/4 plus 1/2 is 3/4, so we get 7 to the 3 over 4. Problem 2, same thing again, we have common bases, it's both a base of 5. The exponent on our top 5 is a 1. And what we do whenever we're dividing common bases is we subtract our exponents. So we're going to take 1 minus 1/3, and we get 2/3. So this would be 5 to the 2/3 power. And problem 3, we're going to start by looking on the inside. So we're not going to worry about the squared for now. We have 42 to the 1/3 divided by 6 to the 1/3. Since those exponents are the same, I can divide the bases. So 42 divided by 6 is 7. It's still 7 to the 1/3. And I still have this squared out here. So again, notice that our exponents were the same. It stayed 1/3. All I did was take 42 divided by 6. Now I can multiply these exponents. That's our power property. And we get 7 to the 2/3. 1/3 times 2 is 2/3. Next, we need to look at a couple of properties using radicals here. So the first thing I really want to point out is if we have a problem going on with radicals is whatever number is in, so whether it's a cube root or a fourth root, it has to be the same the entire problem. So in this example, I couldn't have some of those being cube roots and some of them being square roots. So make sure that your index, your in, is the same for all of them. So this first one, the product property says, if I am multiplying something inside my radicals, I can break it up into two separate radicals being multiplied together. So the cube root of 4 times the cube root of 2 would become the cube root of 8. 4 times 2 is 8. And we can take the cube root of 8 and get 2. Same thing with division. If I'm dividing on the inside here, I can split it up to the nth root on the top and the nth root on the bottom and simplify it that way. In this example, I have the fourth root of 162 divided by the fourth root of 2. I can take 162 divided by 2. I get 81. And then I can take the fourth root of 81 to get 3. In example 4, we have square roots. If you want to, you could put a little 2 in here. You don't need it, but you can if you're curious of what index it is. We can take and do 3 times 12. So we have the square root of 36, because 3 times 12 is 36. And the square root of 36 is just 6. Same thing with problem 5. My indexes are the same, so I have 4 and 4. I can just take 27 times 3, which is 81. And then the fourth root of 81, I get 3. Just a reminder of how to find what the fourth root of 81 is we're saying what to the fourth power gives us 81. So you could try a couple things. You could try 2 to the fourth power, but then you're going to find that 3 to the fourth power is what gives you 81. Problem 6, we have a fraction going on. So we can rewrite this 4 and this 1024 in one big radical, and then simplify the inside. Take 4 divided by 1024. When we do that, you get a decimal. So something else you can try now, if your calculator doesn't turn that into a fraction for you, is say, what can I divide both 4 and 1024 by? I think we can divide them both by 2 because they're both even, but let's try 4. If we divide them both by 4, we get 1 on the top, 4 divided by 4 is 1, and we get 256 on the bottom because 1024 divided by 4 is 256. Now we can take the fourth root of 1 and the fourth root of 256. Well, the fourth root of 1 is just 1. And the fourth root of 256 is 4, because 4 to the fourth power is 256. Problem 7, same idea. We're going to take and rewrite this radical with 625 divided by 5 on the inside. 625 divided by 5 is 125. And the cube root of 125, that's like saying what to the third power equals 125? Well, that would be 5.